So let's solve some of the problems. Here I am showing some of the problems from the NCERT book class 9. So question number 1 is this: a bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. Okay, then find A, the speed acquired, and B, the distance traveled. As it is moving in a straight line and direction does not change, so distance is same as displacement. Is the bus travels moving with uniform acceleration. Here I will put A equal to 0.1 meter per second square and time equal to 2 minutes, so 2 into 60, all in SI system, so 120 second. Okay, starting from rest, so U is equal to 0. So what we have to find, the speed acquired, that means it was here, starting here, U equal to 0, then with constant acceleration A. Now this is time t equal to 0, this is time t equal to 120. You have to find out the velocity and also the distance traveled or displacement, same as direction does not change. Okay, so we have two formulas here we can apply. V equal to u plus at, next s equal to ut plus half at square. Okay, so now for solving any problem, right, for solving any problem, you know, the first work is to choose origin and direction, right? That means say here wherever the bus starts, you choose here this for 0 or displacement equal to 0, and this is the direction, this is the positive direction, and accordingly this the values will have signs. So here it is in positive direction, so A is equal to plus 0.1, so U was 0 obviously. So we will use the first equation to find out velocity. V equal to u plus at, so V equal to 0 plus 0.1 into 120, so V is 12 meter per second. This is answer to A. Now in the next part it is asked find the distance traveled. Distance traveled means this displacement obviously. So S equal to ut plus half at square, so S equal to 0 into 120 plus half a 0.1 into 120 square, so that is half into 0.1 into 120 into 120, so there it's 60. So 0.1, this 0 will cancel, so 120 multiplied by 6, so displacement is equal to 720 meter. Okay. Now some next question. Question number 2. So a train is traveling at speed 90 kilometer per hour. Okay, now brakes are applied to produce uniform acceleration of minus 0.5 meter per second square. Find how far train will go before it stops. How far the train will go before it stops. So here the train, consider this engine of the train, so traveling at a speed 90, so the initial velocity is 90 kilometer per hour. So we have to change to SI system. In SI system, equal 90 into 5 by 18 meter per second. So what we have here, 90, so 18, so 18 into 5, so 25 meter per second. Okay, now for any problem, before the writing all these u, s and whatever, before applying formula, you have to choose a 0. So this is a 0, this is a 0, and this is a direction, this is a positive direction. That is important, because all this u, a, v, s, whatever, they come with signs. Okay, so here it is, uniform acceleration of -5. It stops, means see, the acceleration is this way, so the acceleration this way is 0.5 meter per second square. That means there is a force in this direction, so acceleration in this direction. So what will you write? A equal to minus 0.5 meter per second square. See, produce acceleration of minus 0.5, it is same as the train has retardation. The train has retardation of 0.5 meter per second square. Retardation means if it is moving towards the forward direction, retardation means the acceleration towards the left direction here is 0.5 meter per second square. Okay, find how far it will go before coming to this. So you can attempt in this way. You have this formula, v square equal to u square plus 2as. So suppose it goes s, say distance s, before it stops, say it moves distance s before it stops, then here it stops here, so final velocity is equal to 0. So I am going to put that final velocity is 0 square is 25 square plus 2, in place of a minus 0.5 into s. So therefore s equal to how much? 25 square is 625 divided by 1, so that is s is 625 meters. So it moves a distance of 625 meter before it stops. Next problem. Now this problem is based on motion under gravity. So like this, a stone is thrown, in vertically upward direction, with velocity of 5 meter per second. If acceleration of stone during motion is g, that is 10 meter per second square downwards. For all bodies it is g downward. What will be the height? What will be the height attained? What will be the maximum height attained by the stone? Okay, and how much time it will take to reach there? So this is the question. A stone is thrown in vertically upward direction with velocity. So this is ground. From ground it is thrown upward at a velocity of 5 meter per second. So acceleration is here, that's 10 meter per second square downwards. So again you need to choose the direction and the zero. So this is a zero of the coordinate system, and this is, we choose this as the positive direction. Okay, so we have these all formulas: v equal to u plus at, then s equal to ut plus half at square, and v square equal to u square plus 2s, and we have to choose which one we will use for which situation. Now if the acceleration of stone, so let's put down the values here. So what is given here? U is equal to 5 plus 5, it's in meter per second, SI system, meter per second, and acceleration, as see I have chosen the direction upward, positive direction, and acceleration downward, so I have to write here minus 10 meter per second square. Okay, what will be the maximum height attained by the stone? How much time it takes to reach there? So it goes, so you know, it goes up to a maximum height h, there it momentarily stops, and again it comes down. So there is an upward journey and a downward journey. Okay, so to find maximum height, so let h be the maximum height. Okay, so at maximum height, at maximum height, that displacement is equal to h and velocity is equal to 0. It stops momentarily at the highest point. Okay, then so you have to find h. So the best suited equation for solving this is this third one, because see there I put 0 square equal to 5 square plus 2 in place of a, minus 10 in place of s, h. So h is equal to 25 by 20. 25 by 20 means how much? It is 1.25, right? 2.5 by 2, so 1.25 meter. So the maximum height is 1.25 meter. And the next part of the problem, how much time it will take to reach there. So when it stops there, suppose when it was thrown upward, then time was 0, time equal to 0. Here time is equal to t, this you have to find out. So you can use this, v equal to u plus at. So put v equal to 0, so the time, and so v equal to 0 at time t. Okay, so we'll put here 0 equal to 5 plus minus 10 into t. Therefore, t equal to 0.5 second. So problem solved. Then how much time it will take and how much height it will go. You can substitute and check for this. So at time t, at time 0.5 second, you can put for the displacement. So ut plus u into t plus half a minus 10 into t square. Now this becomes 2.5 minus 5 into 0.25. Okay, so that is 1.25. See, it matches actually. So what we have got in the last part by this formula, h is the displacement at the highest, from this point to the highest point. Displacement is the line joining the starting point to the end point. I mean up to this, from here to here, displacement is the maximum height. 1.25, we have proved it from this equation also. Right, if I add on some more to that same question, for the same question, for what was the question number, for question number 3, for question number 3, suppose find the time at which the velocity of the stone is say 2 meter per second up, and the times at which, right, and 2 meter per second down, right. So you can solve like this. Here this was a 0 and this is the direction. So you have to find this t, find t at which v equal to plus 2 and find t at which v equal to minus 2. See, this 2 meter per second up means plus 2, and there's 2 meter per second down means v equal to minus 2. So let's see, just put in this equation, v equal to u plus at. So therefore v put plus 2 equal to 5 plus minus 10 into t. So therefore t is coming to be much 3.3 second, right. So after 0.3 second, after 0.3 second, it will go up. And let's see here, v equal to u plus at. So put here minus 2 equal to 5 plus minus 10 into t. T is variable, so different values of t you can have. So here you get 0.7, right, t equal to 0.7 seconds. Okay. If I add one more to the last question, so for question number 3, find total time of flight of the stone. Okay, so here you can intuitively you can say that time of ascent equal to time of descent. So time of ascent was how much? We have calculated as question 3. Yeah, it was 0.5 second. Time of ascent was 0.5 second. So total time of flight t, total time of flight will be twice of that, so it's 1 second. Okay. So this is an intuitive way, or you can do it in a different way also, many different ways also. Suppose it reaches here, so till the topmost point, till highest point, time taken is equal to 0.5 second. Now let's start from the highest point, choose one more zero, and this direction positive downward. Now from the highest point, to ground again, right? From the highest point to ground, here we have chosen the axis, and the height was calculated. Initially it was calculated to be 1.25 meter. Okay, so s, so find t, I mean the time of descent from here to here, find t. Yes, I mean you are it's like solving a new problem. Suppose a particle is dropped from a height 1.25 meter. So what is the time? So you assume here time 0, right? You assume here time 0. Okay, so time find time t for s equal to 1.25. so you can have, so again you can put u is equal to 0. Remember, that is a new problem, we are framing a new problem here. So this is a 0, this is the direction, so it's just dropped, right? Moment is reaches the topmost point, it comes to rest. So you can consider it starts from rest, particle is dropped to, drop means its velocity is 0, and here the acceleration is 10 downward. So here we'll put a equal to plus 10. So s equal to ut plus half a t square. So put 1.25, this is 0, plus half 10 t square. So therefore 1.25 divided by 5 equal to t square. Therefore t equal to, here what do you get here, 0.25, so square root is 0.5 second. So we have proved that the time of descent is 0.5 second. Okay. Now there is one more way of solving the problem, where you do not have to change the 0, right? There, what you have chosen is that this is the 0, this is the positive direction, and there, and that is time 0. When it is thrown, it is time 0. So find the value of time when it reaches here. So value of time when it reaches here, that means I can write this equation ut plus half a t square. Now what is s? S is displacement, right? S is displacement. So displacement is a vector, it's a line joining the starting point to the end point, starting point or starting position to the final position or the end point, end position. So here in time t, particle comes back to the same path, right? So it was thrown at time 0. So in time t, particle comes back to the same path. So what is its displacement? Is equal to 0. Its displacement is equal to 0. So here you can put 0 equal to u was plus 5, t plus half is minus 10 times t square. Therefore 0 equal to 5t minus 5t square implies, see here you have this 5t common into 1 minus t is equal to 0. So there this t1 minus t into 1 minus t equal to 0 implies you have two solutions, t equal to 0 or t equal to 1. I hope you know this this roots, right? T has two roots, it has two values, 0 and 1. See, so the displacement is 0 at two values of time, 0 obviously when it was thrown, and after time 1 second, so in 1 second it comes back to the starting point. So therefore from here we can say that time t, time of flight, is equal to 1 second. Now next you also have uniform circular motion in your syllabus. Uniform circular motion, so I'll just discuss that briefly. Okay, so here velocity of the particle is changing, in a circular motion, that is particle travels in a circular path, and this uniform means the speed is constant here, right? Uniform circular motion means the speed is constant, speed does not change, but velocity changes because velocity is a vector quantity. Speed is constant but velocity is not constant. As direction changes, now I'll show you the direction and all this stuff. This is a circular motion, particle in circular path. This is the center of the circle, this is the radius of the circle. So O is center of circle, R is radius of circle, okay, and V is the speed. So here, so it travels a certain distance, say this, what is the t time period, travels the the whole path in what time, which is time period. So this v multiplied by time period is 2 pi r. 2 pi r is the circumference of the circle, right? So its speed is constant. Now its velocity, velocity, the vector quantity, velocity means just speed with a direction, right? So there it is at this point, velocity is this way, this is a vector, the vector is represented by an arrow. So there it is. See, the speed is constant but the direction changes. Direction changes means the velocity is not constant, right? So these are the velocities at different times. Okay, so on circular motion, some one or two problems, let's see. So this is a problem from NCERT exercise. So this will be question number, I think 4, question number 4 today. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. Okay, what will be the distance covered and displacement at the end of 2 minute 20 seconds. 2 minute 20 seconds. So here the athlete goes in the circular path. So let's calculate 2 minute 20 second means 2 minutes means it's uh, 2 into 60 seconds. So 2 minutes is equivalent to 120 seconds. So 2 minutes 20 second, add 20 more, so 140 second. So what will be distance and displacement at the end of 140 second? So this 40 into 3, so I can write 140 equal to 40 multiplied by 3 plus 20. Okay, so the total time means here it makes 3 rounds, 3 full rounds, right? For 3 rounds, and 20 means half round. So for one round it takes 40 seconds, one revolution. So half round. So 140 second means suppose this is the starting point and this is the direction, right? That is the starting point. See it 3 rounds, right? 1 2 3 rounds, 40 into 3, 120 second plus 20, that means here. So this is the initial position, and that is the final position. Okay, so what is the distance and displacement? So obviously distance traveled is so how many rounds? 3 rounds plus half round. So 3 round means 3 into 2 pi r plus half round means pi r. So it's 7 pi r. Okay, so 7 into pi is 22 by 7 into r. Radius is 100 meter, as the diameter is 200, radius is 100 meter. So therefore distance is equal to 2200 meter. That means 2.2 kilometer. And displacement in this time, displacement is obviously this. Displacement is a line joining the initial to the final position. That's displacement. So that is a one diameter, right? 2r. That's 200 meter. And there are more problems in NCERT. You can try those. Okay, let me do one more problem. This last one there is in NCERT. An artificial satellite is moving in a circular orbit of radius 42250 kilometer. Calculate its speed if it takes 24 hours to revolve around the earth. This was question number 5. So that is the earth, and there is a satellite, artificial satellite. Okay, so it's radius. So this radius is given as 42250 into 10 to the power 3 meter, and the time period is given. Time period is 24 hour, as 24 into 3600 second. Okay, calculate its speed. So obviously see that speed is distance by time, so speed is distance means 2 pi r divided by t. 2 pi r divided by t, and you can calculate this as 2 pi 3.14 into 42250 into 10 to the power 3 divided by 24 into 3600 meter per second. That's how it's a good calculation practice.